today is 5-3 day 4, and I'm going to start off with a pre-example leading into what's going to be new for the types of problems that we're doing today. So we've been working for the first few days under solving for the interval 0 to 2 pi. So as a real simple example, 2 sine of x minus 1 is equal to 0. We want to isolate that sine of x, bring over the 1, divide by the 2, and then we go to the unit circle and we find the two solutions, 0 to 2 pi, that satisfy that equation. Well, back to a bigger picture concept, there are an infinite number of angles that you can take the sine of and get 1/2. That just happens to be the two of them that are in the 0 to 2 pi interval. Well, you can't list all the solutions, but we can algebraically describe them. Anything coterminal with pi over 6 is also going to be a solution. So pi over 6 plus 2 pi n, and it's going to be the same type of notation that we did when we were describing asymptotes. With the graphs that had an infinite number of asymptotes, we couldn't list them all, but we could algebraically describe them. And just like with the asymptotes, sometimes you see it with the plus or minus, and then the interval at which they occur, or sometimes you see it with just a plus. Either notation is acceptable on our quizzes and tests. So pi over 6, and anything coterminal with pi over 6, meaning pi over 6 plus 2 pi, plus 4 pi, plus 6 pi, plus 8 pi. Pi over 6 minus 2 pi, minus 4 pi, minus 6 pi, etc. Same thing here. So that's going to be one variation for today. That variation being, instead of solving for 0 to 2 pi, we want to algebraically express what are all the solutions to the equation. Okay, variation number 2. All of the equations we've done so far, in that variable slot right there, it's been a single letter. It's been an x, a t, or a theta, or something that's just a plain old single variable. Well, what if it's something more? Those are known as multiple or partial angle problems. It's a multiple angle problem. If it's times some number, like 3, for example, and it would be a partial angle, which will be the next example if it's being divided by something. So we're going to blend these two variations together into our next example. It says, find all solutions. Sometimes if it just says solve, solve implies it wants them all. So those are the two types of instructions that you want to be comfortable with. Pay attention to if they want just a particular interval, or do they want them all. And the alternate way that you'll see that written is just say solve. I believe tonight's homework out of the book, that's what the instructions in the book say. It just says solve. All right, the way that we're going to do this is we're going to treat that whole 3t as one variable. So we're going to solve this for red box. 2 cosine of red box minus 1 is equal to 0. So we want to isolate cosine of red box, bring over the 1, divide by that 2, and that gets us to an equation that looks just like this one up here. So what we're going to do is we're going to go to the unit circle. Cosine of what angle is 1/2. In the 0 to 2 pi interval, that happens at pi over 3 and at 5 pi over 3. We want all solutions, so we're putting the plus 2 pi n, plus 2 pi n after each one. Or if you want, you can do the plus or minus. Either notation is acceptable. So at this stage right here, what we've done is we successfully solved this equation for red box. We need to solve it for t. So what we're going to do is take this whole solution, divide it through by 3. Take this whole solution, divide it through by 3. So divide by 3, divide by 3, divide by 3. That gets the t by itself. Pi over 3 divided by 3 is pi over 9. 2 pi n over 3 is just 2/3 n pi. 2 pi n over 3, or you can put the n up top in a fraction, it doesn't matter. Do the same set of steps here, and that's our final answer. So the typical flavor you can expect for your final answers when you're working under the find all solutions or just plain old solve is you can have final answers that look like this. Example number 2. This is another multiple angle formula, multiple angle equation, because of the fact that it's not just x, it's 5x. We're working under the directions of we want all solutions. So what we're going to do is we're going to solve this equation for 5x. So for this particular problem, that means that we're going to divide both sides by 3. We're going to square root both sides to undo that squaring. Don't forget, when you introduce an even root to a problem that was not there to start with, you have to do the plus minus thing on the right hand side. That gets secant by itself on the left, number by itself on the right. At this stage, you want to do your flippage. That flips to this, that flips to that. Okay, as a reminder, you only want to do this flippage step when it's a single trig function on the left, single number on the right. If you do the flippage prior to that, you might get lucky and still get the correct answer, but there's a reasonably good chance that it is not going to take you to where you want to be. Okay, so the cosine of what angle is plus or minus root 3? Well, we know cosine is positive in the first and the fourth quadrants. We know it's negative in the second and the third quadrant. So we're going to get a solution in each quadrant. Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. We're doing the plus 2 pi n, and what that does is that successfully solves the equation for 5x. We need to get from 5x to x. So that means we need to take each one of those solutions and divide through by 5. So divide by 5, divide by 5, divide by 5. That gets you the first one. Do the same thing with that, gets you the second one, etc., etc. So these guys right here represent all solutions to that equation. All right, example number 3. We are still working under the instructions of find all solutions. I guess that should have been written up here. You'll either say solve or find all solutions. This time we have a partial angle formula. So instead of something times x, it's x divided by something. Same basic strategy. We want to solve this equation for x over 2. So to make that happen, we're going to isolate the tangent. That 3 comes over. Then we divide by this 3. That gets us to here. So the tangent of what angle is -1? Go to the unit circle. That happens at 3 pi over 4, 7 pi over 4. Now the last 2 equations that we did, or 3 equations, we did a sine, we did a cosine, and we did a secant. The base period for all of those guys is 2 pi. So when we did this little piece right here, we added a 2 pi n. For tangent and cotangent, we're going to add a pi n, because that's the period for those 2 functions. So at this stage right here, we've successfully solved this equation for x over 2. What we need to do is to get this equation solved for x. So we take that whole solution, multiply through by 2, take that whole solution, multiply through by 2. So 2 times the x over 2, the 2's cancel, that gets the x by itself. 2 times 3 pi over 4 is 3 pi over 2. 2 times pi n is 2 pi n. All right, so right here, we're technically done. What I want to do is illustrate for you something that tends to happen with tangent and cotangent equations. What are the actual angles that are being described by this expression? 3 pi over 2 plus 2 pi n. Well, I'm going to give them a common denominator. Common denominator for 2 and 1 is a 2. So this expression is the same as that. So this means 3 pi over 2 plus 1, 4 pi over 2, plus 2, 4 pi over 2, plus 3, 4 pi over 2, etc. So starting here, we're going to add 4 pi over 2. That gets you to here. Then you add another 4 pi over 2. That gets you to here. Add another 4 pi over 2. That gets you to here, etc., etc., etc. Going in reverse, subtracting 4 pi over 2, subtracting 4 pi over 2. So this list of angles is what's being described by that expression. Going to do the same thing over here. 7 pi over 2 plus 2 pi n. That's the same thing as 7 pi over 2 plus 4 pi over 2n. So starting here, we're going to add 4 pi over 2. Add 4 pi over 2. Add 4 pi over 2, etc., etc., etc. Subtract 4 pi over 2. Subtract 4 pi over 2. Subtract 4 pi over 2, etc., etc. These two lists are the same angles. What we end up getting here is a redundancy of solutions. These two guys both describe the exact same set of angles. So being they describe both the exact same set of angles, we don't have to list both of those. We only need one of them. Now, if you check your answers in the back of the book tends to condense redundancies. If this were an odd problem, it would only have one of those back there. So your responsibility doing homework is you'd have to look to check, well, I have two things, the back of the book has one. Why is that? Did I make a mistake, or do we have the redundancy thing happening? It's okay to list both, but you only have to list one. The other place you'd have to be aware of this, if it's a multiple choice question, chances are the multiple choice question wouldn't have both. It would only have one or the other. You need to be able to realize what's going on in order to be able to choose the correct answer. Now, as I had said earlier, this tends to happen with tangent and cotangent. Now, this is a relatively basic equation. There's not a whole lot going on. With the relatively basic, this is a relatively basic equation. There's not a whole lot going on here. The more complicated that this gets, the better chance that it's not a nice, clean redundancy like this. But for the simple ones, like we just went over, this tends to happen with tangent and cotangent. Those are the ones that you want to keep your eyes open for in terms of this redundancy thing happening. Okay, last example for today. We're going to go back to the instructions of the 0 to 2 pi, but we're going to do so with an equation that has a multiple angle. Okay, whether it's a multiple or a partial angle, we're going to take the same approach to this. Okay, when solving partial or multiple angle equations for a particular interval, always solve for all and then list accordingly. So, kind of tweaking what we said in the beginning, as soon as you see a multiple or a partial angle equation, you're always going to initially find all the solutions, whether those are your instructions or not. If you have all the solutions and the instructions are to find all the solutions, the problem ends. If the instructions are to find a particular interval, then you have to do whatever it takes in order to get all of them, from all of them, down to the particular ones they want. So let's see how this plays out. Cosecant of what angle is root 2? Now, if you want to, you can convert this over to a sine equation if you want, but it's a relatively basic cosecant one. If you're comfortable solving it as a cosecant, then go with it. So, in the 0 to 2 pi interval, that happens twice, at pi over 4 and at 3 pi over 4. Cosecant has a base period of 2 pi, so we're putting a plus 2 pi n plus 2 pi n afterwards. This line right here successfully solves for all solutions for 2x. Now we need to get from all solutions 2x to all solutions x. So that entire solution gets divided through by 2, gets you to here. That entire solution gets divided through by 2, that gets you to here. Now, if the instructions were to find all solutions, we would be done right here. That's the end of the problem. Stop at that point. But we don't want all of them. We only want 0 to 2 pi. So what we either have to do is physically list out the angles that are being described by these guys, or mentally visualize what they are, and then choose the ones that fit that interval. So to make the list, I'm going to take this, give it a common denominator. Pi over 8 plus 8 pi over 8. So starting with pi over 8, I'm going to add 8 pi over 8. Add 8 pi over 8. As big as I need to go until I go outside the 2 pi interval. These guys fit the 2 pi interval. That's 2 1/8 pi. So that's outside the interval. Those are just going to get bigger. We don't have to extend that list any further. You always have to consider, well, what if you backed it up? What if you subtracted 8 pi over 8? If you subtract 8 pi over 8, that puts us to a negative number, which is outside the interval. So for this half of our solutions, there are 2 angles that fit in this interval. Okay, now I'm going to do the same thing for this. 3 pi over 8 plus pi over n. That's the same thing as 3 pi over 8 plus 8 pi over 8. So starting at 3 pi over 8, add 8 pi over 8, add 8 pi over 8, add 8 pi over 8, subtract 8 pi over 8, subtract 8 pi over 8, etc. until you identify what fits in the 0 to 2 pi interval. So there are 2 numbers here, 3 pi over 8 and 11 pi over 8, that fit in the 0 to 2 pi interval. So our final answer for this problem is these are the 4 angles in the 0 to 2 pi interval that solve this equation. So, to recap again, summarizing everything we've talked about today, as soon as you see a multiple angle or a partial angle equation, you are going to initially solve for all solutions. If the instructions are all solutions, stop there. If the instructions are for a particular interval, then choose the angles from your list of all possibles of which ones fit that interval. Okay, in the process of solving for whichever your end goal is, treat this thing right here as one big variable, solve for the 2x, and in this case, then take your solutions and divide through by 2. This one here, solve for x over 2, take your solutions, multiply through by 2. Solve for 5x, get your solutions, divide through by 5. All right, so that wraps up what you're responsible for today in terms of taking the next step in trigonometric equation solving. That is dealing with all solutions versus intervals, and that's dealing with multiple partial angles as opposed to just plain old angles, so to speak.